Welcome back, children. I'm Srinivasan here. We are going to discuss about inverse of a function. This is in chapter Relations and Functions. This will help you to solve the problems in exercise 1.3. So, inverse of a function. When an inverse of a function exists and how to find the inverse of a function. The two terms you are going to see now. Let us start with the definition. Definition for inverse of a function, and then we are going to find the inverse. Check whether inverse exists and we'll find. While discussing the exercise 1.2, we have already noted that when a function is one to one onto, inverse exists. Okay, that you please recall that. Now, a function defined as f x to y, x is the domain, y is the codomain. X to y is defined to be invertible, if there exists a function g y to x, codomain to domain. So domain to codomain is a mapping, is an image, and then you are coming from codomain to domain. If you are defining like that, that means inverse. Okay, children, or we call it as a preimage. That is an easy term. Such that GO f of x is equal to ix. It's given in the book. Identity function of x. You just understand it as x. GO f of x equal to x, and f of g of y equals identity function of y, or simply y. You should take it as f of g of y equal to y. You have to prove that. Then the function g is called the inverse of f and is denoted by f inverse. What does this say? The definition says is there exists a function from x to y is defined to be invertible. That is, an inverse will exist for this f if there exists a function g. Another function should exist from y to x, codomain to domain, such a way that GO f of x is a composite function. We have explained in the composition of functions. Please refer that composition of functions video. GO f of x equal to x and f of g of y equal to y. This should be true. Then you can say that function is called the then you can say that g of y or just g is called the inverse of f and is denoted by f inverse. This is one method. By doing sums very easily you can understand. There is another way. Conversely, thus if f is invertible, then f must be 1 to 1. F must be a 1 to 1 function and onto. This is from exercise 1.2. Conversely, in the conversely, if the function is 1 to 1 and onto, then the function is the function f is invertible. F must be invertible. This is one method. This is second method. This method you are a little bit familiar when you are doing 1.2. F is called invertible. F must be 1 to 1 and onto. Conversely, if it is invertible, this must be true. Or if you say the function is 1 to 1 onto, then the function must be invertible. So this is second method. One method, we are going to find GO f of x equal to y, x, and f of g of y equal to y. Then we will say the inverse exists and g of y is the inverse. That is one method. Second method, you will find 1 to 1 and on to, then you will confirm that inverse exists and you will find the inverse. So there are two ways of it. I'll show both the ways now. We'll take a small example to understand this better. First method I'm going to do now. You are defined with your function. Given a function f from x to y, where f of x is defined as x plus 3. I am defining a function f of x equals x plus 3, where f is a function from x to y. Find the inverse of f or f inverse. We'll solve this question. The first method I'm going to do. So f is defined from x to y. Okay. Then you are given with f of x equals x plus 3. Okay, children. Now let us start. I'm going to take this as y equal to x plus 3. I'm going to solve it for x. X is equal to y minus 3. This is nothing but g of y. This x is nothing but g of y, because we have seen that there exists a function g from y to x. So this is the x. I'm going to define it as g of y equals, it's a function of y, g of y. Okay, there exists f of x and we have taken a function g of y. There exists g of y. Now we have to check whether g of f of x is x and f of g of y is y. Then we call that is a inverse exists and g of y is a inverse. Okay, children. Now what are the two things we have to prove? One is GO f of x equals x, we have to prove. Then f of g of y equal to y. If you are able to prove these two things, then you can say inverse exists and g of y is the inverse. We'll confirm. That is g of y. Y minus 3 is the inverse. We can confirm. Let us start with the first one. GO f of x, which means g of f of x. We are going to prove that this is equal to x. G of, what is f of x function? X plus 3. Okay, children, I'm just substituting f of x as x plus 3. Now what is g of y function? Y minus 3. Whatever argument is there, you have to subtract 3 with that. So x plus 3 minus 3. Check with that. G of y equal to y minus 3. G of x plus 3 equal to x plus 3 minus 3. So plus 3 minus 3 will get cancelled. So you have proved g of x, f of x equal to x. Next you have to check f of g of y. This part is over. Next this part, f of g of y. This we can write it as, you are going to prove it as y. Now let us write this as f of g of y. This is the meaning of that. What is g of y? Y minus 3. So f of y minus 3. Now you have to substitute in the f of x function. F of x, what is f of x? X plus 3. Correct? X plus 3. Now whatever x is there, you will add 3 with that. So y minus 3 plus 3. So minus 3 plus 3 gets cancelled, you got y. So you have proved g of f of x is s, x, f of g of y is y. Therefore, f is invertible and g of y is the inverse of f. That is f inverse of y is equal to, what is that? Y minus 3. This is the solution. This is method 1, children. First you take the given function, instead of f of x you make it as y, then solve it for x. This x is your inverse actually, that we will confirm the last. So you take it as another function, because the definition says if f you can define, then there should exist a function g of y, okay, such that these two conditions are satisfied, g of y will be the inverse. So y minus 3 is started, then I proved this 2. So when you are able to prove this 2, then you can say invertible g of y is the inverse of x. So inverse is y minus 3. This is one method, children. Now I am going to do the same problem in a second method. That is, we will prove 1 to 1 and on to, then we will confirm that inverse exists, then inverse is that particular x. Let us do that same. The same question, second method. Shall I? Now let's take two elements, x1, x2 belongs x. we know that this definition you have to remember. We know that when images are equal, then corresponding elements must be equal. You remember that. This is explained in 1.2. You have done all the sums based on this. You have taken starting images are equal, then we will show that corresponding elements must be equal. That idea will do. Let us start. Images means f of x1 is equal to f of x2. I have taken images are equal. Now you have to show corresponding elements are equal. What is f of x? X plus 3. So you write it as x1 plus 3. X2 plus 3. Subtracting 3 on both sides, we will get x1 equal to x2. So you have proved corresponding elements must be equal. Then the function is 1 to 1. The full exercise is done on 1.2. The same model is done in 1.2. Now 1 to 1 is over. To verify on to. If it is 1 to 1 and on to, then you can say the function is invertible. Now take the question y equal to x plus 3. The same what we done in that method we will do here. You solve this for x equal to y minus 3. Okay children, x equal to y minus 3. You substitute this x in f of x. Substituting in f of x. What is f of x? X plus 3. So f of y minus 3, because x is y minus 3, equal to y minus 3 plus 3. Minus 3 and plus 3 gets cancelled. So you get y. So if you get a y, what you will understand? F is onto function. I will write the definition. If you have forgotten the definition, I will write it now. How it is onto function. For all y belongs to capital Y, the domain, if there exists an element x belongs to capital X such that f of x equals y, then the function f is onto. This is the onto definition. For all y belongs to y, you are able to define an x belongs to such that f of x equal to y. See here, we are able to prove that substituting f of x we got y, so f of x equal to y. That's why I told this is the onto function. So f is 1 to 1 and onto, therefore inverse exists. Since the function f is 1 to 1 and onto, f is invertible, or you can write inverse exists. F inverse is equal to the same x. What is x? Y minus 3. This is your inverse. So f inverse you can write, or f inverse of y is equal to y minus 3. This is another method, children. Okay children, mostly we are going to solve in this method. This is a little easier. No need to prove two parts. We will take an first part 1 to 1. Then we will go for this definition and we will complete this sum. Okay children, I hope you understood the two methods. This is about inverse of a function. Based on this, we are going to do sums on the exercise 1.3. Thank you children.